Good morning friends, I welcome you all in this session. As you are aware, in previous session we were solving questions on how to calculate NPV and standard deviation of NPV, and we have seen 3 examples so far. We have seen one example of unrelated cash flow, we have seen 2 examples of unrelated cash flow and 1 example of related cash flow. Let us look at one more example of correlated cash flow, and for that we would be using these 2 formulas. So it is very simple, there is no change in this particular formula as far as this one is concerned as it is. However, there is a change in this second formula, right? What is the change? It is just standard deviation, right, not the variance, right? And here it is 1 plus I to the power t. In earlier formula it was 2t, right? So we will take one very simple example and we will try to solve it, right? So there is a project, so 1, 2, 3, 4, so you have been given 80 values directly, right? And these values are 5, 3, 4, 3, 5, 3, 4 and 3000, right, along with their standard deviation, right? So standard deviations are like this: 15, 1, 1500, 1000, 2000 and 12, 1200, right? So now you can put these values in this particular formula, you will get NPV, right? So this is, let us solve for expected NPV. So that value is, you have got 5000 plus 1 plus 0.06 plus 3000 divided by 1.06 square, then 4000, 1 plus 0.06 cube, and finally 3000, 1 plus 0.06 to the power 4 minus initial investment is 10,000, right? Initial investment is 10,000, right? So this value can be calculated easily, right? And for your convenience, this is 3121, right? Similarly, you can also calculate standard deviation, right? Just take the summation of all these divided by 1.06, then square, cube and to the power 4, right? So you will get standard deviation also, right? So with this we come to the end of this particular method. What was this method? It was Hillier model, right? Let us move on to another method of calculating risk, and this method is simulation analysis, right? So we have seen several methods. For example, we have seen sensitivity analysis, right? We have seen scenario analysis, right? We have seen Hillier's model, and let us look at one more, simulation analysis. Though we did discuss little bit about simulation analysis, but we did not solve any example, right? So in simulation analysis, as you are aware, we apply simulation analysis in highly complex situation when even mathematical modeling is also difficult. Generally we apply simulation when future is quite uncertain, right? So we do not know what will happen, only we know is the probability of occurrence of some events, right? So we will use the information which is available in the form of probabilities to find out answer to a question, right? As we have seen that sensitivity analysis and scenario analysis, they give lots of information, but they are not adequate. For example, in sensitivity analysis we have seen that if we decrease sales, then our NPV would also decrease. But what is the probability of that decrease in NPV? So, to calculate those probabilities we use simulation tool, right. So, in simulation when we carry out simulation there is a procedure for it. So, first of all you need to model the project. When I say modeling of the project, it means how your NPV is related to different parameters, right. Parameters means those variables which are under the control of decision makers, and there are some exogenous variables which cannot be controlled by decision makers, right, and they are stochastics in nature and as I said not controllable, but we know the probabilities of those exogenous variables, right. So, second point in this is specify the value of parameter and probability of exogenous variables. So, from past data you can find out probability of exogenous variables, right. Then in simulation generally we come up with random numbers, and these random numbers are available in books of statistics, in books of financial accounting, project management and so on. So, we use random numbers to solve the problem. Why we use random numbers? Because our data the input data are mostly random in nature, right. So, to solve that particular problem we have to use random numbers. The fourth point is determine the NPV for set parameter, the controllable as well as for uncontrollable variables. Repeat step 4 and 5 number of times, right. So, you can have 10 runs, 15 runs, 10,000 runs, 20,000 runs and so on. So, manually if you do this type of question it is very difficult, but using computer you can run several simulations, right, several runs for a simulation model, right, and then at the end of the day you can plot frequency distribution of NPV, right. So, NPV the frequency distribution of NPV can take different shape, right. So, we do not know what shape NPV distribution will take. It may take normal distribution shape or a triangular distribution shape or step distribution shape and so on, right. So, it all depends on the probabilities of exogenous variables and the random numbers, right. So, we will take an example, and this is very simple method. The simulation analysis is very simple. NPV is equal to summation of 1 to n, right, multiplied by annual cash flow divided by 1 plus risk free return to the power t, right, minus initial investment, right. So, similar to what we have seen, this is the formula. Let us take an example wherein we have been given two exogenous variables along with their probability distributions, and let us take risk free return as 10% and initial investment in this case is 13,000, right. So, let me give you what are the probabilities of exogenous variables, and I will also write down different random numbers which we would be using for solving this particular question to calculate NPV, right. So, the question is like this. So, you have been given annual cash flow is given along with probability. So, annual cash flow is 1000 and its probability is 0.02, let us say 0.02, right. 1500 probability is 0.03, 2000 probability is 0.15, then 2500 probability is 0.15, same for these two, right. 3000 probability 0.30, 3500 probability is 0.20, and for 4000 0.15, right. So we will be using Monte Carlo simulation to solve this particular problem. So these are cash flows and probabilities, right. So this is first exogenous variable, right, which is not under your control, right. The second one is project life cycle. So this is, let us say this is value and this is annual cash flow, right, first, and the life cycle is second exogenous variable. So this is in terms of years, right. So 3 years probability 0.05, right. So this is probability, right. For 4th year it is 0.10, for 5th year it is 0.30, for 6th, 7th, 8th, 9th and 10th. So for 6th year it is 0.25, for 7th year it is 0.15, for 8th year it is 0.10, for 9th year it is 0.03, and for 10th year it is 0.02, right. And let me also give you random numbers which we would be using for this particular question, right. So the random numbers we will be using 2-digit random numbers. Random numbers, as I said, can be generated through, let us say, computer, or you can have, let us say, you can note down different chits, write 2-digit numbers on 100 chips, and those numbers would be from 00 to 99, right, because you want 100 chits, right. So put all those chits in a box and then you pick up one chit, right. So that would be a method of generating a random number, right. So either you use this method, or you can generate it through computer or through Excel, or there are random number tables available in books, right. So we will use, since you have got 2 exogenous variables, so you need, and these are 10 points, right. 1, 2, 3, 4, 5, 6, 7, 8, right, 8 and 8, right. So you need 16 random numbers. In fact, how many random numbers are needed, it depends on how many runs you want in your simulation, right. So these are 16, 8 values for this cash flow and 8 values for life cycle. Now you can go for 10,000 runs also. So for 10,000 runs you need 20,000 random numbers, right. So in this particular question we are going for just 10 runs, right. So for 10 runs how many random numbers are needed? 20 random numbers, 10 for this and 10 for this, right. So those 20 random numbers are like this. So first of all I will be writing random numbers for this one, right. So random numbers are, so first random number is 53, 66, 30, then 19, 31, 81, 38, 48, 90 and 58, right. So total 10 random numbers. So this first, second, third and so on, right? So this is 10th random number. So these are called random numbers, right? So for project life also you can have random numbers, and these random numbers are 97, 99, 81, 9, 67, 70, 75, 83, 33 and 52, right? So these are 10 random numbers for project life cycle, right? Okay. So how to proceed now? So this is the question given to you. We want to calculate what would be the NPV, right? So first of all, what we should do, we should assign tag numbers to these probabilities, right? So let us first assign tag numbers for cash flow, right? Okay, so let's say value is 1000, 1500, 2000, 2500, 3000, 3500 and 4000, right? Probabilities are also given, so 0.02, 0.03, 0.15, 0.15, for 3000 it is 0.30, and for this is 0.20 and 0.15. So first of all, calculate cumulative probabilities. Cumulative probabilities, right? So how to find out cumulative probabilities? 0.02, 0.05, 0.20, 0.30, right? It's 0.35, right? 0.65, 0.85 and this is 1.0, right? Now once you are done with cumulative probabilities, let us assign tag numbers to these probabilities, right? So how to proceed? It's 0, 0 to 0, 1, right? So what is the meaning of 1000 and probability is 0.02? Its meaning is that out of 100 times the value of cash flow was 1000 only for 2 times, right? So for first time we have assigned it 0 value, and for second time we assign it to 1 value, right? Similarly, so 1000, 1500, 2000, I hope we have not missed any value. 1, 2, 3, 4, 5, 6, 7. No, I think we have missed. Did we miss any value? 1, 2, 3, 4, 5, 6, 7. Yeah, we didn't miss, right? Okay. So what would be the tag number for this? This is 02 and 04, right? Keep in mind, since this is 5, right? If you multiply all this by 100, then this would become 5. So this number should be 4. This should become 35. So the end number should be 34. This would be 100. So the ending number would be 99, right? So this is how you should assign tag numbers. So for this 5 to 19, right? Then 20 to 34, 35 to 64, 65 to 84 and 85 to 99. So these are nothing but tag numbers we have assigned, right, for this one, right? Similarly, assign tag numbers for life cycle also. So let us look at this. So life cycle in terms of years. So 3, 4, 5, 6, 7, 8, 9 and 10, right? probabilities are given, right. So this is 0.05, 0.10, 0.30, 0.25, 0.15, 0.10, 0.03, 0.02, right, and of course you can write 0 here, right. Now what is the next step? We need to find out cumulative probabilities, right. So cumulative probabilities 0.05, 0.15, 0.45, 0.70, 0.85, 0.95, 0.98 and 1.0, right. Similarly, now assign tag numbers for life cycle also, right. So tag number, so this is 002, 04, 5 to 14, 15 to 44, 45 to 69, 70 to 84, 85 to 94, 95 to 97 and 98 to 99, right. Now we will find out NPV and we will go for 10 different runs, right. So let us look at first run. This run 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, right. So for first run, what is the random number? 53. So random number is 53. Now what would be the value of cash flow for 53 random number? So just look at where is 53 in this particular tag number column, right. So 53 is here, it means this value would be 3000, right. The next random number is 66, okay. Now look at where is this random number in this particular column, in tag number column, right. So 66 is here, it means value would be 3500. Next 30, right, 30 is here, it means this is for fourth, right. So this is 2500. Fourth random number 19, so let me write other random numbers also, 31, 81, 38, 48, 90 and 58, right. Now this 31 is here, right. So this is again fourth, right. So this is 2500. 81 is here, right, it is 3500. 38 is in this one, right. So this is 3000. 48 is in which range? It's here, right. So this is 3000. 90 is here, right. So this is 4000 and 58 is where? It's here, right. So this is again 3000. So what we are saying, these are the values corresponding to these random numbers. The moment you change random numbers, these values will change and your NPV will also change, right. So answer depends on how you are choosing random numbers. The random numbers should be truly random numbers, right. Okay, so this is the value, right. Now this we have done for ACF, right. Now let us do it for life cycle, right. So first run, so this is for ACF, right. Let us do it for life cycle, right. So I will use different color pen. Life cycle. So So first run, right, let me write run number here, right, run number. So you have got 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, right. What is random number? Random number, you have got 97, 99, 81, 09, 67, 70, 75, 83, 33 and 52, right. Now what you want? You want what would be the life cycle, right, in terms of years, right. So for random number 97, where this 97 lies in this column, it's here, right. So life would be 9 years, right. Next, can you try 99? 99 is again here, so 99 is in this range, right. So the life would be 10 years, right. Similarly for 81, 81 is in which range? Here, right. So life would be 7 years. For fourth run, random number is 9, 9 is here, right, it means 4 years. For 67, 67 is here, right, it means 6 years. For 70, 70 is here, right, again 7, right, 70 is here, right, so 7. 75, 75 is in which range? Here, right, so this is again 7 years. For 83, 83 is where? Here, right, no, it's here, right, so again 7 years. 33, when random number is 33, 33 is here, right, so 5 years. 52, 52 is here, right, so 6 years. And now you can calculate NPV using the formula which I gave you, right. Formula is here, right. So you use this much, all these values and calculate NPV, right. So let me also you can apply this formula and find out NPV of this particular project. So 9, 10, 7, 4, 6, okay, yeah, so this is perfectly all right. So NPV would be 4277, 8506, 289, 7660, 2112, 4039, 1605, 1605, 2163 and 66. So this is how you can use simulation method for finding net present value. So let me summarize what we did in this particular method. In simulation analysis, as I said, is to be used at in a situation where it is highly complex. So you have got some controllable variables, some of them are uncontrollable variables. For uncontrollable variables, you have their probability distributions. So use probability distributions to come up with tag number, and then you will have to use random numbers, and random numbers will decide what would be the answer, right. If you change random numbers, your NPV will also change. So you can solve the same example by taking now random numbers. First is let us say use these random numbers for cash flow and random numbers for this set of random numbers for life cycle, and then find out how your answer changes. So with this, let me complete this session. In next session we will see some other topic. Thank you very much.